Hello, good morning to all. Today we are going to see about deadlock in OS.
Let us consider two processes, process P1 and process P2 in an operating system. Consider two resources the system has, that the processes need to access.
Consider process P1 has to do some task. To perform the task, process P1 needs to utilize resource R1.
So, the operating system allocates the resource R1 to process P1. Now, resource R1 got allocated to process P1. Similarly, process P2 also has to do some task. To perform the task, process P2 needs to utilize resource R2.
So, the operating system allocates the resource R1 to process P1. Now, R2 got allocated to process P2.
Consider a situation where process P1 needs to utilize resource R2. But process P2 is currently using R2. So, process P1 has to wait for P2 to complete its execution. Once process P2 completes its execution, process P1 can request the resource and utilize it. Consider a situation where resource R1, which is already allocated to process P1, is requested by process P2, and resource R2, which is already allocated to process P2, is requested by process indefinitely to free the resource. This results in deadlock. This is called deadlock in operating system. Deadlock can arise if the following four conditions hold simultaneously: mutual exclusion, hold and wait, no preemption, circular wait. Deadlock prevention. The method we are gonna see about is mutex.
In this method, the resource is held inside a critical zone. That is, whenever whenever a process enters the critical zone, no other process is allowed to enter the critical zone. Now, if process P1 wants to utilize the resource, it will enter into the critical region. Now, process P1 performs the task by utilizing the resource which is present inside the critical zone. Now, when process P1 completes executing the task, it will stop utilizing the resource and get out of the critical region. Then, if P2 wants to utilize the resource, P2 will enter into the critical region. Now, process P2 performs the task by utilizing the resource which is present in the critical region. While P2 is performing the task, when P1 tries to utilize the resource, it will be denied by the operating system itself. Once the process P2 completes executing its task, it will stop utilizing the resource and get out of the critical region. Now, the remaining process, that is P1, is authorized by the operating system to utilize the resource. As seen earlier, now process P1 enters the critical region and performs the task by utilizing resource, and when it finishes, it will come out of the zone. In this video, we have seen about deadlock and its prevention techniques. Thank you for watching this video. Thank you.